Late, late. Shame, shame for shame. So it is 2:01 UTC on the 21st of July, 2018. It's unbelievably fast year. They say, I guess, as you age, that's what happens, right? Um, so yeah, I'm trying to get used to that. It's pretty tough. It's pretty tough. Things are really flying by, and I mean that in a literal sense as well as a figurative sense. So let me get started on the smartphone here. Hope everybody's doing well. You've stumbled onto a live stream called Astronomy Daily Live, and what we do here is we take a little time out of each and every day to, you know, turn off the TV, forget about the news, uh, and think about galaxies and stars and telescopes and nebulae and comets and distances and time and, you know, eyepieces and mirrors and detectors and cameras. Uh, and then, even sort of the far out stuff we can get into, if you want to, well, yeah, I mean, if you want to get into black holes, dark matter, all of that, we can think about that too. A lot of those, I I was actually thinking about this the other day. I am trying, I guess, sort of subconsciously, and maybe I'm going to bring that uh, more into my consciousness. And that is, I think, subconsciously, I'm trying to actually avoid sort of the mainstream, what what uh, what other podcasters and live streamers are talking about in terms of the popular things, right? Black holes, dark matter, dark energy, gravitational waves. Um, yeah, I guess I'm sort of purposely avoiding that because that seems pretty um, saturated, right? Um, Exoplanets, right? Exoplanets is a big deal now, right? I mean, I totally understand, right? I mean, it's very cool, but you know, I as far as exoplanets go, I'm not. I mean, I'm very pleased, but I'm not surprised at all. Uh, you know, it would be outrageous, I think, to consider the idea that our star was the only one that had planets. Um, that that's outrageous. So the only thing, I mean, it's sort of just using logic a little bit in that it's such a large sample that yeah, I think even if the probability is low, it's still going to be a large number. And what we're finding, right? What we're finding is that every single star has a series of planets around it, and who knows what else, right? So, so I'm extremely pleased about that. That's extremely cool. Um, but I'm the sentiment that I get in sort of the community, right, is surprise. It's like I can't believe that there's all these planets out there, and I think exactly the opposite. It's like, of course, there is. We just have to, we just have to be able to see them. That's all. And you know, I still need to look into this in more depth, and I actually have I think I do have the papers. There's a series of 3 papers that the Kepler spacecraft people put out describing how they detect a transit and how they confirm that it actually was a transit and not a false positive, um, and and then collect data on it in terms of its period and all of that. And so I need to read those 3 papers because I'm not sure uh, necessarily what the difference would be between say a long-lived sunspot um, that as the star rotates, you're going to get this dark spot, right? I don't know what the difference is between that light curve and the light curve of a planet transiting that star. That's that's one of the fishy things about all these detections is that in order for us to see these transits, right, everything has to be aligned really, really, really well. I mean, micro arc second um, uh, um, angles, right? I mean, really, really, really small things. And for things to align that well so often makes me really scratch my head. Because yeah, it's and maybe, yeah, I mean, look, in order to see a transit, right, that planet must pass in front of that star. It must. Now it can pass at any angle, right? But it has to be orbiting uh, in a plane such that when we look at that star, it's crossing the disk of the star. And for that to be aligned, I don't know. Hmm, yeah, not quite sure what to think of that. But as I said, what really needs to happen, right, is a reading of those papers, and not only a reading of those papers, but an understanding of them, because I mean, it's probably pretty complicated, I would think. So yeah, so that is the skeptic in me, right, saying it's like, well, are we really seeing, are all of these really planets, or are they something else? One of the other things that sort of bothers me about a lot of these extrasolar planets is that they have orbital periods around their stars in hours or days, right? I mean, if you think about it, right, Mercury, the closest planet to the sun, is some 36 million miles away. Um, and it has a year of about 88 Earth days, right? Its year is about 88 days, 88 days. But and that's a little rock, going around this big star. Um, uh, but here we're looking at these exoplanets, and we're seeing huge, huge, huge planets, right? Super Jupiters, right? That are um, these big things. I mean, we're seeing other things too, right? Super Earths and Neptunes. We're seeing all kinds. At least we think, right? But but in order for you know one orbit to be hours or days, that planet has to be like super super close to that star. I mean, super close. Um, and so that to me is a red flag too. So it just, I don't know. I would think that maybe the stars could be rotating themselves, maybe in hours or days. So that's why, my thought is that it's like, well, maybe it's some kind of like a permanent or semi-permanent sunspot, right? And as the star spins around, we're just seeing it. I don't know. I don't know. I don't really have any theories. I'm just saying that, the the uh, the excitement over exoplanets is very, very cool. I fully support it. Um, but being surprised that there are some um, doesn't surprise me one bit at all. It's, I mean, my response to that is, well, it's about time, right? And when we find life, I will say exactly the same thing. It's about time, and that's all it. I mean, that's all it really is just a matter of time. I'm going to pull up the chat. I haven't done that yet. Hey there, Daniel Browning. Nice to see you in the chat. I think you're new, so howdy, howdy, howdy. Nice to see you. They're finding exoplanets in very unusual places, triple star systems. I think they're finding exoplanets in globular clusters. So they're sort of finding exoplanets everywhere. So anyway, my main point is that I'm really not. I guess sort of subconsciously, I'm not really um, trying to follow sort of the mainstream. What you're going to hear about anyway. Uh, I like to talk about the things that are overlooked, that are extremely cool, right? Very, very cool, and for me at least, makes me wonder. It's like, what is going on, right? So I've I've got the coffee here tonight. So cheers. It's getting it's not quite as hot as what it was a little while ago, so it's cooling down fast. Cheers. Australia. Wow. Daniel, you made my day. That is very, very cool. Hope everything is well over there. You get at least where you are. Do you get much of a winter, or are you pretty far north? What's the story? But in any case, hope everything is well. Wave, please wave to the Magellanic Clouds for me. That is something that someday I would really, really like to see. Um, haven't yet. Probably never will. Probably, but you never know. Never, ever know. And I would like to, also see the southern sky, to experience what I experienced as a kid when I first went out under a dark sky and was completely lost, right? Just completely overwhelmed and lost. And I am absolutely, that that kind of thing can happen to a person uh, just a couple of times, right? I mean, uh, you know, more or less, depending on what latitude you are on Earth, you're either going to see a northern sky or a southern sky, and so you get used to that, right? Uh, but there's that one point where you first see that first sky, and for me at least, I was completely lost. I mean, I could not find anything at all, and I was pretty at by that time. I was pretty familiar with the sky that I could see from the middle of a city, right? So I was pretty familiar with the shapes of most of the brighter constellations, but when I got out under a dark sky, where you can see to sixth magnitude, all of a sudden those second or third magnitude stars I could see um, in town just sort of got washed out with all the other stars. It was absolutely amazing. So yeah, yeah, polar alignment is easier over here. Yeah, you would think so, but of course the problem is that, um, and maybe it isn't a problem. Um, Now that I'm thinking about it, having an offset from a bright star that's in the same field of view, um, yeah, I think that does make it a lot easier. Yeah, do you have any idea what sort of the brightest star is next to the South Pole? Um, yeah, let me know. But yeah, who knows? I might get down there. Who knows? All right. So I was looking at this comet that's it's had a couple of outbursts, and it had one a little while ago, and then it dimmed back down, and I guess it's having another outburst now. So I thought that we could just, I don't know if anybody's ever seen these kinds of things that I'm going to show. So I like, as I said, I like to show things that maybe you usually don't see. So let's see, can we open the original? Uh, yep, that's okay. No, I did not forget my panelist.
Yeah, it's
Hello,
like, what's
panelist.
the deal?
Hey, I start talking about astronomy, and the rest, I mean, everything else just absolutely vanishes. So, what's going on, Bobby?
Nothing much, and nothing much here. What about you?
What do you think about Daniel down in Australia? I think that's pretty awesome. It's it's about noon there or so, Daniel. Is that right? It's about noon.
Yeah, I want to know where in Australia you're from, Danielle.
Sure. Just general area. Be as specific as you wish. And
Uh,
Astro YYZ is also in the chat. Thanks for subscribing today. I noticed that you did that, so thank you much.
uh,
Mm-hmm. Yeah. You know what? Let's there's a I wanna is it the Heavens Above site that has a nice list of the current comets? Let's uh let's sort of follow our nose here with that. Melbourne. Cool. Yeah, I've got a colleague in Melbourne. Um, he's a well, he's a computer guy, but I guess what he's trying to do, and I don't know how successful he is at this, but he's making and selling um, kettle corn. So Daniel, if you're in Melbourne, you may know this kettle corn guy. I don't know. Maybe. Let's look at the list of comets. So Heavens Above is a great site. Usually, what I use it for is just to look for satellites. Space station, um, HST, right? anything exciting. You can also look up all the like the ham sats, um, if you're into that kind of thing. Yeah, it's great, 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 great site. Um, but we're just going to look at the list of current comets. So yeah, nothing too exciting, but I think this is the one here. C 2016 M1 PANSTARRS. So PANSTARRS is the observatory, I guess, that discovered it, and I guess that was back in 2016 is when they found that comet. Let's see. Jacobini Zinner is back. Actually, I think there are quite a few Jacobini Zinners. Um, I uh, I think the first comet that I ever saw was at least one of the Jacobini Zinners. Um, it was really, really faint and everything else, but I was sort of revving up for Halley's Comet that was going to be coming in the next year or two. Um, so yeah, I wanted to get some experience with the comet observing, before I actually you know did it for real for Halley. So yeah, nothing visible, but this plot. Okay, so here let's go down here. You can see this is the month, May of 2018, June, July, August, September, October. So um, it's it's going to be at its brightest, of course, when it's closest to the sun. So that's perihelion, and it looks like perihelion is going to be what, somewhere around what, August 10th, something um, like that. Apparently, and it's not going to show it here, but apparently um, that's like on the opposite side of the sun from us. So we're
And
not.
and what's that comet called again?
I think this one is, yeah, Comet C 2017 S3 PANSTARRS.
Okay.
So that's this one, this guy.
All right.
So he's up in Auriga. If you know where Capella is, this is sort of a northern constellation. Here's Perseus. Here's Cassiopeia over here. Um, oh, this must be a zoomed in area. Not quite sure. Yeah, so perihelion is about 1/5 of an AU, so pretty close. Now they're saying that the eccentricity of this thing is higher than 1. And to me, when an object has an eccentricity greater than 1, that means it's on either a parabolic or maybe even a hyperbolic orbit. So they're saying that this is on a one-way trip. It's coming in and it's going out. That's what that's saying right there. That number is anything greater than 1, then it is inbound from infinity and outbound to infinity, at least mathematically speaking. So didn't know that. That might account for the outbursts, right? So these little dots represent the measurement of the brightness of the comet. And as you can see, that's sort of shown on this axis. And so these numbers are magnitudes. So the top line that you can just barely see, that would be a magnitude negative 0.5. So just a little bit brighter than Vega. So Vega is magnitude 0. And then it goes, 1, 2, 3, 4, 5, all the way down to 24th. So they pick this up, at least this plot, right, is showing first measurements, in like the first week of May or so, when it was really, really, really faint. And then over time, right, it's getting brighter and brighter and brighter. And these two gray lines are models, right? So they put in various parameters. Not quite sure what the parameters would exactly be, and then they can ask the model, okay, at this time, right, on June 1st, how bright should it be if we look at the model? And the model says, okay, should be that bright. And in July, it should be that bright. In August, it should be that bright. It should peak at that brightness at that time. So these two models are showing, at least, that it could peak at either like magnitude 4, which is pretty bright. I mean, that is visible, or brighter than magnitude 0, which would be exceedingly bright. And as you can see, what they try to do here is they try to, they're overplotting the actual observations, and it seems to be on its own path, which is extremely typical, right? It's like, down here. See, now they're not showing any error bars or anything. They're just showing data values. So these are going to have some kind of measurement error, right? Which could be pretty significant, big enough, in fact, to have them included on both of those lines, right? So we really don't know what's going on here. The interesting thing is that up here, it sort of looks like that the data is favoring this red line, which, if you just extrapolate out, this might end up being a pretty bright comet. Unfortunately, we're not going to see it at its brightest, because, as I said, I think it's on the other side of the sun or on our side of the sun. In any case, it's going to be too close to the sun from our point of view in order to see it at its brightest. And I think it's probably too far away to see in any of the solar telescopes, like those wide field ones. I don't think you're going to be able to see it in that. I think it's too far for that. I'll bet you, those two solar spacecraft, Stereo A and Stereo B, I'll bet you they're going to get a good view. So they'll probably be using those to look at that.
Now, on my curiosity, Astro YYC says he was able to image the comet from remote scope. Can you name me like a site where you can get into remote scopes like this?
Yes, the one I like is SLOOH. So it's SLOOH.com, and for $5 a month, you can take, I think, like 3 pictures, 3 images. They have 5 telescopes over on the Canary Islands. Here, let's go over there. And they have 1 telescope in Chile, and they're not huge scopes. They're I think on the order of like ½ meter or so. So they're not small either, right? Maybe they have a 14-inch, so that'd be like a third of a meter or so. But for $5 a month, you know, you can use any of these scopes, uh, um, and let's see. Yeah, I'm not going to log in. Um, but there it is, slew.com. Now for $25 a month, I think you have, do you have unlimited? I think you have unlimited um, capabilities, right? So what you do is you set up a, what do they call them? Um, let's see, can we go here? Schedule telescopes. I want to get their terminology. Um, I've got to be signed in. All right. You can get a free um, a free account, which is what I have.
Yeah, but you gotta pay for it to use the scopes, right?
You have to pay to use the actual scopes. Yes, that's absolutely true. Um, what I was looking for was the, oh, right. They call it a mission. So you set up a mission, which is just, I want the telescope to point either at, you know, a particular object or a particular position in the sky. Uh, and, you know, you tell it how long of an exposure, you say which filters you want to use, all this kind of stuff. Um, and then you can even tell it when. Uh, and then it goes and does it, drops the data in uh, uh, in your folder, and you can take it off of that and do what you want with it because it's yours. So it's a great, great, great business model, and it seems to be really popular. And I'm extremely impressed with these guys. I think uh, they're let's see, can we go? Yeah. Um, is absolutely fantastic. They have all sky cameras, um, which are live. Let's see, can we do this all sky? So there it is, as of 2:30 UTC. So as of 4 minutes ago, this is what um, they're seeing. Now, for some reason, they're asleep. Not quite sure why, because it looks clear. Obviously dark. You can see the Milky Way here. That's obviously Mars. Here's Saturn over here, just north of Sagittarius. You see that? So there's about the center of the galaxy, right? Yeah. Well, sort of down here a little bit. So it's um, setting at this
Now,
point.
if there was a free trial, how many you could have it as a free trial?
I don't think that there are any free trials. You can sign up for free and have access, to their site. But yeah, I think if you want to use any of the scopes, you have to, get on their one of their plans. But I think this is absolutely fantastic. Here's the summer triangle. So Deneb, Altair, and Vega, and you can actually see Cygnus here and Aquila, and you can just sort of see Lyra there. It's those four stars right there, and of course Vega. Now right here is Sagitta, right? Remember M71? M71 is right about there, and the dumbbell M27 is just off of the end, so it's just It's just over there. But you can sort of see the North American nebula up here. It's next to Deneb. And Mars just dominates, though. That's insane. So yeah, and this is I'm updating. They're about 4 minutes behind us, but not bad. Not bad. You know, get a good shot of the sky from the Canary Islands. Uh, let's see, down to Chile. See how it looks down there. As I said, I'm really impressed with these guys. Um, they know their stuff. They have a pretty regular podcast, and you know they know their stuff, and their site is fantastic. It's got to be dark there. Getting dark. Okay. So you can see that Mars is much higher in the sky, right? Because its latitude is different, right? Canary Islands, are they? They're they're north of the equator still, yeah. I think so. Um, I need to catch up on the chat. Um, cool. 24-inch scope, nice. Imaging comets is it's probably not as difficult as you think. You do need to be able to track it, so you know you get star trails, because the comet is moving against the background differently than the stars are moving. So you have to, if you want to do like long exposures, you have to be able to track the motion of the comet and not the motion of the stars. So that's the only real complication. But those, the that kind of tracking can be calculated and then fed into the computer that runs the telescope. So not a big deal. Mars crazy. Mars crazy. Yeah, well, enjoy. It is pretty awesome. I mean, it does happen every year, right? It happens every year. But this is a little nice because it's, unusually close. And that's very, very cool. It makes it very, very bright and, gets people thinking and talking about Mars. Nothing wrong with that. But yeah, there's a lot of, I'm seeing, I'm not sure what exactly I'm seeing here in this shot. I mean, there's Mars. I'm trying to figure out like where. I think I'm seeing things upside down. I think Mars is like really, really. Well, it's leaning towards the south. Go ahead, Bobby.
So, how you like that Cosmo Quest that stream on Twitch earlier?
Oh yeah, they were talking about the Parker Solar Probe.
Yeah.
Yeah. No, I think it's extremely cool. They keep saying that it's going to touch the sun, and it's like, no, it's not. I mean, it's really not going to get in. I mean, it's going to get closer than we ever have gotten, but we are certainly not going to be touching the sun in any. Yeah, I think they're getting. She said to like a quarter of an AU, so 1/4 of the way between um, um, the Earth and the Sun. So that's really close, right? That is really, really close, but it's definitely not touching the sun. So I really don't like that PR. Yeah. I just don't. I don't think it's necessary, right? Um, But I guess, you know, how else are you going to say it? I don't know.
Yeah.
But yeah, I, they're actually supposed to launch on August 6th on a I think it's a, do they call it a Delta 4 Heavy? So it's like the biggest, baddest rocket um, around, because this thing needs a serious push. Um, and yeah, I think the Parker Solar Probe has a pretty long journey ahead. I don't think it's going to be in sort of a science orbit around the sun for another 7 years. Um, I think, in fact, it's even doing some kind of encounter with Jupiter, because really, what the Parker Solar Probe has to do more than anything else is it needs to slow down, right? It needs to be moving slower uh, because it needs to get close to the sun. So, you know, it has to dribble off a little bit of speed in order to change its position. So I guess it's going to do that, you know, with some help with Jupiter. And I think Venus is going to be involved. Not exactly sure what the path is. Anyway,
Yeah.
um,
I
uh,
just like wish that it will help you with that with radio propagation, but Pamela Gay did say that the SDOs is much more better than the PSP.
yeah. I don't know. It's um, you know, this is the kind of mission where they're like, well, let's send up some instrumentation that we think might be interesting and see what happens. So
And
it's
hey,
that kind of.
Raider Astro YYC, have a good night.
All right, Astro YYZ, thanks for coming in. That's very, very awesome. Thanks for the subscription. Um, See you next time. Come on in anytime you want. Always, almost always here, 2 hours UTC. So, okay, I'm going to get back to this guy. So, yeah, there is a possibility, right? I mean, if you extrapolate out, it's like, well, this thing looks like he's brightening quite a bit. So, this was the first outburst, right, that happened earlier in the month, right, where it just got, you know, all of a sudden went from what, 11th up to 10th, 9.5, 9, right? So I mean, it increased in brightness two magnitudes, right? Which is, every magnitude is a factor of 2.5, so it's 2.5 squared in this case. So it increased in brightness by a factor of 6.25. So that's pretty extraordinary. And I guess what they're saying, at least the latest news that I heard, was that it was once again in outburst. Now it's kind of interesting, right? This, if I'm looking at this highest point here, that's saying almost 6.5, and Heavens Above still has it at 8.5, 9.5. So they need to update. Okay, last observation was the 16th of July. It was 9.5. Hmm. See, I like to look at these things and just sort of see. Okay, well, maybe they're calling this an outburst, because yeah, I mean that is getting pretty seriously bright, pretty quick. So we'll see. We'll see. Maybe we'll have a naked eye comet here. Wow, we haven't had a naked eye comet in quite a while. I'm trying to remember. Whoop. Let me. I'm trying to remember the last time we had a naked eye comet. It's been that long. It really, really has. So yeah, maybe this will be the one. I mean, if it is on this eccentric orbit that looks like a parabola to me, or a hyperbola, then this comet has come in from very far out and is going back there. Ooh, big thunder crash here.
Oh, that ain't good.
Boom. Thunder's awesome.
You ever listen to Garth Brooks, Thunder Rose?
The what?
Garth Brooks, the Thunder Rose.
Yeah, yeah, yeah.
Yeah.
All right, well, cool. What else should we do? We've got a little bit of time. Got a little bit of time here. That's the biggest problem I've got, and it's a good kind of problem to have. It's like there's so much that we can talk about. It's like, how does one narrow it down to one or two things? It's tough. It's tough when you have access to the entire universe. It's pretty tough. Pretty tough. I'm sort of in the mood maybe to make a picture with some HST images, and I'm trying to think if there's any particular object. I can't really think of anything, so let's just let random.org do it. We'll see what we see here. So I'm going to share this again. Random.org, and we'll have it pick out an NGC object, and then we'll go see if the HST has looked at it, and if so, we'll grab the images and see if we can make a picture out of it. Right, here we go. Ready? 1110 NGC 1110. Let's see. I don't need all these screens up here. So I'm going to, where am I going to go? I'm going to go to that. So NGC 1110. So we'll just look for everything. Now the chances are extremely slim, but we've been pretty lucky lately. So, but I'm just giving you fair warning. Don't get too attached to NGC 1110, because if there's no picture, I'm going to move on. Here we go. Ah, nothing. All right, let's pick another one. How about 5042? 5042. 5042. Let's see. Not a chance. No, nothing. It's going to be one of those. It's going to be one of those live streams, huh? 1505. We gotta do it sometime here. 1505. I don't know what these are. Probably galaxies. Nope, not that one. And 6308. 08. Here we go. Come on. Ah, nope. Dang. 2739. Man, we're running through them tonight. 27. Just skipping over, billions of stars, just like, oh, there's nothing there. Who cares? Nope. Oh, dang. 3396. All right, come on. Come on. Ah, there we go. All right. Finally. So let's okay, I think STIS, I think that's just spectra. Let's find out what this is first. Okay. Before we look at any data, let's just find out what this is. See, I'm looking at the NGC number 3396. That's going to have a right ascension. Let's see. 3396 divided by 7840 times 24. It's going to have a rate of ascension of about 10 and a half hours or so. 10 and a half hours puts it around Leo in terms of right ascension. Or in terms of declination, we really don't know where it is. So I'm going to say this is likely to be a galaxy. But I'm afraid that the HST data might all just be spectra, which is interesting enough. Uh-oh, what is it called? 3396.
You forget quite easily to go back to random.org.
Yeah. So it is a galaxy.
Galaxy and a pair of galaxies. Wow.
Yeah. Let's well, I'm going to hold off on the picture. It's let's see, what kind of galaxy is it? Morphological type? I'm not quite sure how to interpret that. Some kind of merging galaxy? I don't know. I'm not quite sure how to interpret that word. That's a new one. It's moving away from us at a pretty good clip. And yeah, it's at a right ascension of almost 10 and a half hours, just a little bit past. Looks like it's pretty close to being in the constellation of Leo. I would say plus 32. Maybe it's a little bit north of Leo. Not sure. All right, well, let's see what we've got here. I think STIS is a spectrometer, though, so there may not be any pictures. And it looks like this is all STIS. Yeah, and that's all there is. So, well, let's see. Oh, it is an image. Yay. Okay. Looks a little overexposed, but don't really know what they're doing with it. We can find out. We can look at the proposal, not the actual whole thing, just a little thing. So the solar, blind, and long slit capabilities of STIS will be used to investigate the population of hot stars in galaxies. Imaging of galaxies with pic 2 has indicated the presence of knots of blue stars in many galaxies. It's been suggested that these knots may be young globular clusters. Images of the galaxies in our sample in the ultraviolet and visible bands will determine whether such knots are present. Since many of the galaxies are known to be strong emitters in the ultraviolet, it is likely they contain populations of hot young stars. The imaging will be used to identify the location and strength of these knots. We'll then select a slit orientation or orientations for STIS to obtain ultraviolet spectra of as many knots as possible. So yeah, that's what I thought. I thought STIS was a spectrometer, but that looks like an image to me. What do I know? It's a pretty funky looking galaxy for sure. Something interesting is going on there. Now, a lot of this is noise, right? I mean, this exposure time is such that it's picking up a lot of extraneous noise. So most likely, right? The speckly things here aren't real. It's just noise. But we are seeing structures, right? Lots of, I guess, what they're calling knots. So that's a pretty wild looking galaxy for sure. I wonder if so this is a different proposal, but it looks like it's at 3 different wavelengths. So let's look and see, because I can make a red, a green, and a blue out of that. See? Oh, those are spectra. Okay, so these are ultraviolet spectra. You can see absorption lines and emission lines. These all correspond to various elements and/or molecules in whatever they're um, observing. So, and this is in the ultraviolet, right? We're going from what, around 1100 angstroms up to just above 1700 angstroms. So that's pretty far in the ultraviolet. Cannot see this from the ground. You have to get above the atmosphere in order to see things in this wavelength. I'm seeing a series here. You see this, and then this, and then this, and then this, and then this. That looks like a series. That might be the signature of like one particular atom has a series like that. Maybe. I'm just making some wild interpretations of yeah, I have absolutely no idea what these elements are, but obviously there's absorption and emission. So very cool. Can't make a picture out of that though. Nope. So that's that. Let's see. This is interesting. It has a Mervis, so maybe infrared. Oh, preview for this observation not available. Yeah, we didn't actually. So this galaxy hasn't been looked at in quite a while with HST. Yeah, that looks like that's about it.
Not enough pictures to make a cover picture, huh?
No. Nope, just not there. Well, let's just look at this. We can sort of turn this into an object of the day. Let's look around and see what else is going on around this actually shaped galaxy. So maybe interacting with that one. There's a lot of stuff out there. Look at all that. Here's a little group over here. Here's another little one here. I think these are foreground stars. That's my guess. Let's zoom in a little bit. Oh, here's a bright one up here. Zoom in a little bit, see what these guys look like. Oh, he's pretty. This nucleus here seems a little off center, right? You can sort of see the galaxy sort of like that, and this isn't in the middle. It's off to one side. That's kind of kind of strange. Pretty cool. Just, floating islands of a few 100 billion stars. That's all. Nothing to get excited about. So that's 3396. 3396. Let's see what else we got on this bad boy. So, actually pretty bright. I don't really think you're going to see this with an 8-inch. You're going to need a 10 or a 12 or a 14 in order to really start seeing it. V magnitude 12 and a half. Yeah, that's not incredibly bright. It's not incredibly faint either. A bunch of different names, of course. Quite a few references. That's nice. It's it's an unusual galaxy, so I'm not really surprised that it hasn't been studied more than most. Let's see how far away we think this thing is. So pretty good agreement, right? I'd say maybe like 28 megaparsecs. So wow, that's pretty far. A megaparsec is 3.26 million light years. And then I'll multiply that by 28, say. So, yeah, that's pretty far out there. 91 million miles. Light years. So, yeah, that's not too bad. And these are in pretty good agreement, too, in terms of velocity. How far away we and it are moving away from one another. What, 1,700, 1,600 kilometers a second? What do we got here? I don't know. See if there's anything interesting here. These pictures are usually very small and sometimes not really easy to understand, but let's take a look here. Oh, yeah, I don't know what PACS is, but it looks like an image, right? This is offset from center in arc minutes, so it goes from about 5 over here to -5 over here, and from -6 to +6 here, arc minutes. So that looks like some kind of an image. I know it's kind of hard to see from where you are, but okay, not quite sure. Okay, this is looking, I could just barely see it. This is 100 micron, and this is 100 and, I think 160 micron. So this is in the submillimeter range. So we're looking at basically microwave radio wavelengths here. Pretty cool. Pretty cool. That's what it looks like all these are. So let's see, let's just look at one more maybe. So it looks like, okay, so this is 70 micron. And I think that says 160. So yeah, they looked at it, a few different wavelengths. Pretty cool. It's different, right? I mean, the general shape is about the same, but you're seeing different things. So, and that just means, that there is different stuff, which is cool, which is very awesome. We like to know about stuff. let's look at a few of the papers, and then we'll get out of here. Diffuse X-ray emitting gas in major mergers. So maybe this is a merging galaxy. And that's, the idea, right, is that if you have two galaxies that are colliding or merging, it's actually pretty unlikely that any of the individual stars are going to collide. I think that's probably going to happen, but it's not going to happen all that much. But for sure, when these objects run into one another, gas and dust and everything are going to collide, and that makes for some, pretty exciting time. So maybe that explains the clumping. Is that these galaxies are interacting in some way, and stirring things up, and causing star formation when it may not otherwise occur. Galaxy pairs, galaxy groups. And what is this? 3396? Yeah. For some reason I can't keep that in my head. So let's just look for 3396 and see if there's any. Oh, there we go. Chandra observations. So Chandra is a X-ray telescope in orbit. So that's an interesting one. Maybe we should do that. Star forming knots. Yeah. Observations and modeling. Complex radio structure. Cool. Wow, there's a lot of possibilities here. They did a spectroscopic study back in 1970s. Wow. Well, look at that. They've got a photograph of it from 1920, published in 1920. Should we? Okay. Let's see if we can see a picture of this thing from 1920. As I say, a lot of these things, if you want to get into the history of any astronomical topic, this is great, There it is. Amazing. This paper is almost 100 years old, and in fact, didn't they say that the observations were from 1917 to 1919? So these images that we're going to be looking at here, if it's here, are 100 years old. All right, here we go.
This is almost like a centennial old paper.
100 years old, yeah. And as I said, the photographs definitely are. I'm not seeing any. I'm not seeing any pictures. Oh, this thing is frozen up on me. Come on. Too much for it. Come on, you can do it. I want to. They should have a picture of it, shouldn't they? I mean, the name of the paper is Photographs of Nebulae, right? Well, let's just page through it here, I guess. Come on. Okay, so there's a big list. A long paper. Come on. Okay, here's some. No, I don't see it there. Is this the first? I need to go back and see if this is the first. For some reason, it's really not wanting to go back. Okay. I'm going to X this out. Let's see what page I'm on. Page 5. Page 6. Okay, so this is the beginning. So let's see if there's any more. There's got to be more. Yeah. Okay, no, not seeing it there. Hopefully, we'll recognize it when we see it, right? Because we've seen the modern images of it. There it is. Pick that out right away. There it is. Very cool. Let's confirm. Let's look at the caption. Yep, 339596. Very cool. So there's a 100-year-old shot of that. I'm trying to zoom in. Zoom in one more. Is it going to let me? Come on. Oh, scoot you down a little bit. So there we go. There's a 100-year-old shot, and here's an HST shot. Let's. I think that first one was probably the best one I saw. Was it that one? I don't remember which one it was now. No, that's the spectrum. This one? No? Where was that now? I don't remember. I thought it was that one. Wasn't that an image? It's a spectrum. Oh, where'd that image go? Let's look at this one. No. Could have sworn we saw the first thing that we looked at was an image, I thought. I don't know. It's not there. Anyway, there it is. 100-year-old shot of NGC 3395. That's this one. And NGC 3396, which is our object of the day. Very cool. Taken somewhere between 1917 and 1919. There's a pretty weird one too. Look at that. Very cool. So this is the 60-inch. This was taken with a 60-inch scope. Let's find out where that was. 6-inch reflector. Are they going to say? Oh, Mount Wilson, I guess. Very cool. All right. I think it's time that we exit these waters. I am getting the message through the headphones. That oh yeah, they are definitely calling. They are pleading. It's like you got to get back up here. So all right, I'm going to get out of here for now. Cheers to all.
Yes.
So have a great evening, great day, and I will see you again in a little less than 23 hours from now. Just a little less than one spin around. So Daniel, thanks for coming in. It was very, very awesome. Feel free to come in anytime. This is a daily live stream, always happening at 2 hours UTC. So, if you want to come in every day, come on in. If you want to come in every other day or every week, every month, whatever it is, feel free. Um, just having a little bit of fun for like an hourish or so, looking at some astronomical objects, thinking about all things astronomy, uh, and just sharing the passion with a bunch of friends. It's great. It's great. So, all right, I will see you all on the spin in, as I said, a little bit less than 23 hours from now. All right, take care, everybody. Peace and cheers.